Hey, good morning everybody, it's Mr. Mott and Mr. Scott. We're going to be showing you guys our types of reactions. We're going to start out, we got our Bunsen burner on, nice blue flame. And we're going to start out with the reaction of some copper metal. So here we got some copper metal. Okay, so you see it's kind of a brownish.
There is breakfast this morning in the cafeteria. The military is.
Hey everybody, it's Mr. Mott. What we're going to do is we're going to show you our 5 different types of reactions that we've covered in class. So first one's going to be a combination reaction. We're going to take some copper metal, and so you can see copper is kind of a nice goldish brown color. And what we're going to do is we're going to heat it in the presence of oxygen. On the surface of things, it might seem like we're just heating up the metal, so we just have maybe one reactant. But in this case, the other reactant is oxygen, which is in the air. All right. So here we go. Start heating this up. And I think what you can see now, you can see a nice green color that forms when you have a reaction with copper. Sometimes you get a nice green color that forms. This happens with some different flame tests as well. So it's kind of a cool, another little interesting fact about when you heat copper up. If you see some different light forms and it's green, most of the time it's going to be copper that you're heating up. Alright. The other way we know a chemical reaction occurs now is that we have our copper, which is a nice brownish orange color. You can see now it has that black covering on there, that black coating, which is copper oxide that's formed on the outside. So by heating up the copper in the flame, we've accelerated the rate at which copper reacts with the oxygen. All right. So that one, since we're dealing with 2 elements, copper and oxygen, combining into one, that is going to be a combination or a synthesis reaction. All right. Next reaction we're going to show you is a reaction of copper carbonate. Okay, copper carbonate is a nice green powder, and we're going to heat it up. Now in this case, this is a decomposition reaction. So we're just taking one reactant and we're going to heat it up and decompose it. Whenever you're heating something up on the Bunsen burner, you want to point the mouth of the test tube away from anybody. Okay, that's just a good thing to do. We can see that there's some steam coming out of the test tube. Water is one of the products that forms here. So we're actually heating this up, and we're actually going to form some copper oxide. So it's actually, again, that black substance that we made before. Making some, we're making some carbon dioxide gas and some water. And as we heat this up, it's just about all reactive. We're getting a nice brown powder. And since we made carbon dioxide as one of our products, we're gonna go ahead and test for that carbon dioxide. And how we're going to do that is, alright, I'm going to light this wood splint and let it burn for a second. Okay, I'm going to blow this flame out, put that in, and what we can see is that the glowing ember went out because there was carbon dioxide in the test tube, and carbon dioxide is more dense than air, so that carbon dioxide stays in the test tube. And it's also not flammable and does not support combustion. So to have combustion, which the glowing ember was combusting, you need oxygen. Since there's no oxygen in the test tube, when you put the glowing splints in there, it went out. All right. That was our decomposition reaction. All right, everybody. We're going to do another reaction here. And so what we have in the test tube is just some ammonium carbonate, just a white crystalline powder. It's got a pretty good odor to it, and just by itself here. So we're going to heat this up. And so this is another decomposition reaction. We know that because you only have one reactant. If you only have one reactant, the only thing you can really do is break down. And so as we heat this up, what we're noticing is that our ammonium carbonate, our reactant, is decomposing. You'll notice in the neck of the test tube, you'll see some gas forming there. We definitely have that going. And in just a few seconds here, I believe all of our reactant is going to disappear. All right, it's going to turn into, I think, 3 different gases: ammonia gas, turning into water vapor, and carbon dioxide. So and it's just about gone. So again, this is a decomposition reaction. We know we can identify a decomposition reaction because you only have one reactant, only one chemical you're dealing with. The only thing you can do is break down. All right, that's our decomposition reaction. Okay. Okay. Now we're going to look at a single replacement reaction. So we've got a little piece of aluminum. All right, we're going to drop that into our test tube, and what we're going to do is we're going to add some copper chloride solution. Our copper chloride is a nice green-blue color, and so we're going to add that in here.
Just a reminder for those of you that were absent or just joined us, your paperwork doesn't follow these 2 chemicals for our single replacement, so we made an adjustment there.
All right, so we see a really vigorous reaction with the aluminum and the copper chloride. And how you recognize or be able to know this is a single replacement reaction is that when you're dealing with an element, you're reacting with a compound, that's going to be a single replacement reaction. Okay. Another way to think about it is if you have something that's single on either side of your reaction, then you know that it's going to be a single replacement reaction. Okay. So right now, another thing you can do to test that, is this a chemical reaction? It is getting very, very hot. Okay. At the very bottom, you might be able to see that the solid that we have in there now is turning kind of a brownish red color. And there we go. Sometimes from the heat, everything kind of gets lifted up, and then the gases. So we can see our solid in there is turning red-brown. That's actually copper we're making. So we went going from our copper ion, okay, which was our copper solution, to the copper solid. And once this reaction sort of goes to completion, what we'll also see is that the solution or the liquid went from that green-blue color to a clear color. All the copper that caused our green solution in the beginning is now clear because that copper is now turned into copper solid. Ooh, that's getting pretty warm. So you can see now, you can see a little bit more, hopefully, of the copper forming, and then the liquid is pretty much clear at this point. A little hard to tell because the reaction is going so vigorously, and the heat that's being produced is causing those bubbles. It wasn't a gas that was forming. All right, so that's our single replacement reaction of aluminum and copper chloride solution. And all right.
Alright, hi everybody, I'm Mr. Scott. I'm going to show you a reaction called a double replacement reaction. So right here we have some chemicals here. We have the iron nitrate, okay, and then here I have some 3 molar sodium hydroxide. So for a double replacement, if you remember it right, we've got 2 things switching partners. So the metal ion from one reaction, the iron in particular, is going to switch places and grab hold of the hydroxide from the other chemical. And then the sodium here will go along with the nitrate. So they're going to basically both switch partners. So I'm going to go ahead and grab some of the iron nitrate, put it into the test tube. You'll notice the color is now a little bit lighter just because it's not as much in that test tube. And I'm going to go ahead and take some drops of the sodium hydroxide. And when they switch partners, you might notice what happens here. You see that, guys? So that is a solid, also known as a precipitate, that's forming. And for those of you that remember from first semester, you could check your solubility chart and figure out which solid that is. And it turns out it is the iron ion from this bottle with the hydroxide from the other bottle. Those two make a solid precipitate when they meet up inside that solution. So that's your reddish brown solid. And then you can take this out if you wanted to and put it in a centrifuge and spin that around and actually decant your liquid, and then leaving you this solid. So that is a double replacement reaction. And then the last one that we're going to show you today is pretty simple. It's just burning a candle. So when we take a look at burning a candle, you're supposed to make a lot of observations. One thing that I noticed is that I hadn't paid attention to the little things in burning a candle. This is our combustion reaction. And if you look closely, some students pointed out to me that there is a slight blue flame